Hello guys, this is my internship project that is automatic washing machine simulation that's powered by basically EMERTEXE. So basically in overview that C is the powerful language widely used in software developments and firmwares, and its efficiency and probability. It supports various number of systems like decimal, octal, hexadecimal and binary. Data is represented in bits, bytes with the data types including integral types like character, int, float values like double, conditional constructs in C including the single iteration statements like if else, switch case and multi-iteration loops like while loop, do while for unconditional constructs include break and continue to flow control. So next slide is we learned from embedded C. We use the operators to manipulate operands and return values. The array stored data of the same type with the sequential uh, addresses, pointer enable, parameter passing by reference in functions. Function can pass by value or reference, return arrays, and use recursion, strings, and sequences of characters, typically ASCII values, and storage class like auto, register, static, and extern manage variable scope and lifetime. So microcontroller is an integrated circuit that is designed for specific tasks with all the components on the single chip, offering low design complexity but less flexible. In contrast, um, a microprocessor has separate components providing more flexibility but increased complexity. When choosing a microcontroller, consider the following application like price, availability of tools, special capabilities. So next slide is embedded system is the software are the systems which combine hardware and software to perform specific tasks. They are characterized by standalone and real-time networked or mobile. Challenges include efficient input-output, embedding on OS code, optimization, testing and debugging. Real-time systems are classified as hard real-time like live critical applications like real-time with strict deadlines or soft real-time with tolerance for delays. So here software we have used is MPLab, IDE, PixumLab and X8C8 compiler. So for the project, the simplest feedback devices in the embedded system, we interface PIC165877A microcontroller on a PIC Genesis board. Basic LED program that toggles connected to port B. The program written in MPLab IDE compiled of hex file that is loaded in the PixumLab for simulation. Next slide. So what is MPLab and IDE? So basically they are free tool by Microchip Technology for developing embedded applications on PICs and DCPICs microcontrollers. It supports project management, code editing, debugging, and programming for 8-bit, 16-bit, and 32-bit uh, PIC microcontroller. It runs on a window and highly configurable. So in Pixum Lab is a real-time annulementer for development boards integrated with MT X or Arduino IDE for debugging. The X8 compiler supports C programming for 8-bit PIC microcontrollers. So it runs on both programs on Windows, Mac OS, and it is universally compatible. So PIC 16F877A. So its feature is its 40-pin microcontroller with RISC architecture featuring 256 bytes for electronically erasable PROM. So self-program and LCD interface, two computers, light 18-bit ADC channels and multiple communication interfaces like SPI, I2C. It has 5 port A to E and 3 timeliners and making it ideal for embedded projects like simulation and all. So this is the board shows that Pixum 168 It has basically LCD. This is the architecture of PIC 16F877A board. This board architecture integrates the microcontroller with the ports of external devices. Port A to E handles I/O operations and port D to E used for LCD interfacing in the project, as we'll see later. Next slide. So next slide is that CLCD or character liquid crystal display comes in the 16 by 2 or 16 by 4 configurations and display ASCII characters and symbols. It has 16 interfacing lines with D0 to D7 as data lines, RS register for selection and RW for rewrite. And in this project, D0 to D7 connect to port D and RS and enable pin connect to port E. Data is processed either the delay method or the pole D7 method with the enable pin signaling data transmission. So this that is the tactile switches in the Martix keyboard are configured in a row as outputs given in the pull up interface ensures proper signal levels with resistor R1 10 times greater than R2. Switches use edge level triggering and we account for the bouncing effect we supervise, ensuring to accurate input detection. Then next is Martix keyboard. The Martix keyboard save I/O lines by a row or a column configuration commonly used in devices like telephones and calculators. In this project, it's using for washing modes with the keys star for clear and hash for enter. Tactile keyboard provides a bump and response for user feedback, enhancing usability in selective washing machines. Then comes timers. The PIC 164877A timer operate in modes like PWN, counter and pulse width measurement. So timers use ticks for counting, quantum for system clock setting, scaling for pre-post scaling and resolution register width. In this project, timers control washing durations with the 8-bit resolution for toggling LED and setting operational modes for like micro and grilled modes. So washing machine simulation using Pixum Lab. So now we'll start the washing machine simulation. So first is we have written the code, then we will run that uh, what you say that code we have written in that MPLAB compiler. Then we will run that. First, it will say like press key 5 to power on the washing machine. So first we need to select the clock frequency as 20 megahertz. Then it will power on the washing machine is in on mode. Then we have 11 modes, that is daily, heavy, delicates, and for stain washing something we have 11 modes. Then this key is used to select and this is used to power on. Delicates, white, stain wash, then eco cottons. We can select the types of cloths, whatever we have according to our need. Eco wash woolens, bed sheets, blankets. Then we can select the water levels, that is auto, low, medium, maximum. According to our need we can select. Then it will say this type of like press switch SW5, that is this one to start and this one to stop, SW6. So setting up washing time we can select from there, that is for woolens it is 29, and after washing the clothes it will just say that from like process completed and just remove the cloths and the buzzer will on. So now let's see the demo. So This is the code we have written here for that washing machine. We have buzzer.c, clc.c, digital keypad, interrupt status register. This is why it's not working. Yeah, this code. And main.c will basically first it will take inputs. We have 11 input. SW4 is used to turn on the that we have after that we have so many options like daily, heavy, delicates, white, stain wash, eco, cottons, woolens, and after that we can select auto, low, medium, high, maximum. So delay is 500 here, and program display, then power on the washing machine, then conditions for what condition you have to require, which how much time. So now let's execute this. So it's necessary to select the clock frequency as 20 and mode as PIC 16 F877A. So LCD display I is using 16 into 4. So load hex, then already it is I have taken. So yeah, it's telling press SW5 to power on the washing machine. So we are selecting SW5, that is this thing. The washing machine is powered on. Then it is asking from this button RB3 we can select the washing machine, which operation we need to perform. There are total 11 operations: daily, heavy, delicates, whites, second, delicates, whites, stain wash, eco cottons, woolens, bed sheet, rinse and dry, dry only, wash only, aqua store, daily, heavy. So to select that, for example, we are selecting heavy. So we'll long press this key. So now it comes water level. So water level consists of auto, low, medium, high, max, auto. So we will select their automatic mode. So to select, we will again long press this. So it's saying that press switch SW5 to start and SW6 to stop. So SW5 is this one. We'll start. Since we are taking heavy, timing for heavy is 50 minutes, but here we are taking for seconds. So motor is rotating. To pause, we can press 6. See, motor stopped working. This all process stopped. So to start again, we will press V5. Wait. Yeah. So it's using retentive timer. So it will save the progress of whatever last time it was there. So So operations also changing. Before it was washing, now it's spinning. Operation completed and remove cloths. Yeah, that's it.